Hello folks, we are in section 2.2 and now we're looking at example number 3. So it wants you to find a polynomial function that has the following zeros. So we have, for the first one, 0 as one of the zeros and 7. So you have to almost think of this as working backwards to get to your function. So we have the solutions, and so we're just working the process in reverse. Now, looking up above, we can kind of get a little bit of a clue on how to proceed. So in this case here, we did have x equals 0 as one of the zeros, and we also had a 0 here of 5 halves. But what you can do is kind of think of it in reverse. So if I know that 0 is one of my zeros, I could say, okay, well that means x equals 0, and then we got x equals 7. But to try to get it to look something like this, I'd have to rewrite not the first one because it's already equal to 0, but this one, if I wanted it equal to 0, I'd have to move the 7 onto the same side of the x. So by subtracting the 7, I get x minus 7 equals 0. Now I'm going to show you a quicker way after this, but for now just kind of keep following me. So what did we do after that, or before that? Once we had them separated so that both of them were equal to 0, we could then now put them together and set it equal to 0. So that's what we're going to do here. So we're going to take the x and the x minus 7 and set it equal to 0. And so now the last step is to get rid of the 0 and change it to f of x. And now if you wanted to multiply that through just to make it look pretty, you could, but you could also just have left it and it would have been fine. Now, depending on what the software, the WebAssign says, you might have to be careful with that, but they'll be pretty descriptive in the directions of how they want it to look. So, but that would be it. Now, can we do this easier? And the answer is yes. So let's go back up here to these different variations of what a 0 actually means. So we have this first statement, but remember, this third one is another way to say the same thing. So if x equals a is a 0, then x minus a is a factor. And that's what we want to use when doing these problems. So I can immediately jump to saying, okay, well, 4 is a 0. So if 4 is a 0, I'm going to say x minus 4 is a factor. Negative 3 is a 0. So x minus a negative 3 is a 0. Now, can that be a plus? Yes. Positive 3 is a 0. So that means x minus 3 equals 0. And then the last one is 0. Now, again, just to keep following the same pattern, I could write that as x minus 0 in parentheses. So now I have my polynomial function, so let's clean it up a little bit. Now, x minus 0 is just x. Now, I don't like it at the end of the polynomial. I like it in the front, so I'm going to just move it there. And now we still got the x minus 4, and then we got the x plus 3, and then we got the x minus 3. So that is the polynomial function. Now, obviously, if they want it multiplied all out, we have to do that. So let's do that real quick. Let's multiply the first two together first. We can distribute that x in pretty quickly to get x squared minus 4x. And what about these two? Do you remember the shortcut for that one? Because they're very much the same, except one's got a plus and one's got a minus, we can do this pretty quickly. If you FOIL it out, those inside and outside products are going to cancel. So all you're left with is x squared minus 9. And now the last step, we can FOIL this out one more time. So x squared times x squared is x to the fourth. You got your inside, which is going to be a minus 4x cubed once you put all the x's together. Your outside, which is going to be a minus 9x squared. And then your last. So minus 9 and a minus 4x is a positive 36x. And so that is your answer. So this idea of using factors to create your polynomial is pretty powerful. Now what about something that's a little bit funky? We don't always get nice singular numbers for zeros. Sometimes we might get something that looks like this. Let's see if there's a trick to this one. Now I'm going to use square brackets. Because this is a more complicated zero, I'm going to put those in parentheses. And so if we put those in parentheses, I'm going to need square brackets to really define the factors. So you'll see what I mean. So remember, we're always subtracting the zero, whatever it is. So I'm going to subtract this first zero of 1 plus square root of 2. So there's my first factor. Second one's going to look very, very similar. So x minus the second zero. Now, we could tackle breaking this down one of two ways. One of them's the yucky way and one of them's the nice way. The yucky way would be to actually try to FOIL this out, keeping this as thinking of that as a singular number. You know, so we'd say x times x, which is x squared. We'd say, okay, my outside is x times this whole thing. Inside is this times this, and then my last is that times that. You're going to get a real big rat's nest of numbers and letters and everything else. Here's a way to do it a little bit easier. So I'm going to take this negative sign and distribute it into these parentheses. But then I'm going to group together the x and the minus 1. Because when I distribute you, I'll get a negative 1 there. So I'm going to say x minus 1, and then when I just, so that gives me my minus 1 here. And then when I distribute the negative onto that, I get a minus square root of 2. So not much change, just a distribute and a reallocation of my parentheses. I'll do the same thing on this one. So I'll distribute, which gives me a minus 1, and I'll group together the x minus 1. And then when I distribute the negative onto the second one, now it becomes a plus square root of 2. So they kind of just reversed roles. But why is this better? Now you can use your trick that we did before with the x plus 3 and the x minus 3. We can cheat and see that the inside and outsides are going to cancel. That's going to happen here. If we think of this x minus 1 as one singular nugget, and we multiply those together, that's our firsts. So I'm going to say x plus 1 times x plus 1 is x minus 1 times x minus 1 is x minus 1 squared. My inside is going to be a negative square root of 2 times this. My outside is going to be a positive square root of 2 times that. So those are going to cancel. So you don't even need to write them down. So your inside and outside cancel, and then your last is going to be the negative square root of 2 times the positive square root of 2. So that's going to be a negative. Square root of 2 times square root of 2 is 2. So a lot nicer end result versus trying to FOIL it the way it was originally. Ugh. So now we can finish it off pretty quickly. Let's FOIL that out. So if we FOIL it out, we should get an x squared minus 2x plus 1 minus the 2, and now we can combine those constants. So x squared minus 2x minus 1. Gotta love those blurps. So, all right. So then the last little conclusion before we close this video. When a factor is repeated in a polynomial function, such as in example 2a, how it affects the graph of the polynomial function depends on the power of the factor. I'll let you think about that, and we'll come back to that in the next video. See you in a sec.